Hi everybody, so we are live now. This is going to be probability lecture number 4. So this session will be only for next you can say 30 to 40 minutes. Okay. Uh, Today the session is going to be for next to 30 to 40 minutes. So I'll talk about the idea of conditioning. Okay, because we have to start discussing about total probability theorem as well as the Bayes theorem, but today I'll talk about the basic thing, the idea of conditioning first. Okay, so this is lecture number 4 on probability. Okay, so I hope many of you are getting benefited from these sessions, and I'm very delighted also that whenever I share my concepts to all, irrespective of the branches, like I'm mentoring for data science and AI. I'm mentoring for electronics and communication, electrical engineering, and instrumentation. So I think before gate examination, I will be achieving my target. Okay, I'm pretty determined to share all the concept of whatever I know since past many years. Right. So this is going to be lecture number 4, and I'm going to talk about the conditioning. Right. So idea of conditioning. What is this idea of conditioning? Right. And then I'll talk about conditional probability basically. Okay. So idea of, you can say, conditioning. Okay. This is very important idea that you have to understand always, right? So as I told you that we have already computed the you know, the ordinary probabilities. Suppose we have got any sample space and there is one event, okay, called A, right? So we can find the probability of that event, right? That is very simple. Okay, that is very simple to compute, in fact, right? The probability of any event. But what is this idea of conditioning? What is the meaning of conditional probability, right? That we have to understand here. So the idea of conditioning is nothing but what? Suppose we can take one you know, sample space, and there will be two events, basically one event and there will be one more event. Okay, so the idea of conditioning is nothing but use new information to revise a model. Suppose you have got some model here, right? So we are going to use new information, okay, to revise, you can say, the initial beliefs or revise the model. Okay, so you will be having some sort of a probability, a prior probability, you can say, right? Ordinary probability. Then again, you are going to you know, use the new information and kind of put the condition and all, right? So suppose we have got one situation here. Let me take one situation. So suppose you have got 12 equally likely outcomes. Okay, so suppose this is a sample space, and you can say that there are 12 equally likely outcomes, right? So I can just take 12 equally likely outcomes. In this, there are 12 equally likely outcomes. Okay, in this sample space. So the probability is going to be what? For one outcome, the probability of getting one outcome is going to be 1 by 12 because all are equally likely, right? And then you can say that suppose this is going to be one event A, right? And which has got you can say 5 outcomes inside this. So one outcome is this, one outcome is this, one outcome is this, you can say one outcome is this, one outcome is this. There are 5 outcomes in this event A, and there is one more event, you can say B, right? So there is one more event, you can say, from here to here. This is going to be B, right? In B event, there are how many outcomes? You can say 6 outcomes, right? So one outcome is here, one outcome is here, right? And one outcome is here, one outcome is here, and already 2 outcomes you can take from the event A, right? So there are total how many outcomes till now I have shown you? 5. Okay, 5 plus 4, and there should be 3 more, right? So you can say 1, 2, 3. So in this sample space, there are 2 events. This is B event, you can say, and this is A event, right? So suppose you have, suppose the you have got 2 events, right? A and B. So if someone is going to ask you what is the probability of getting this outcome, right? So probability of getting this outcome is going to be 1 by 12 as far as the all the outcomes are equally likely, right? All the outcomes are equally likely, so you can say always like this. Okay, so you guys can also like keep asking question also if you have any doubt, like in the chat box. Actually YouTube has changed some sort of YouTube has done, so you can scroll the comment box and you will find the live chat. Okay, there you can always write everything. So suppose they are asking what I want to explain here is that, so suppose somebody has said that, somebody is asking that what is the probability of A, right? So you can always find the probability of A. What is the probability of A here? The probability of A is going to be 5 outcomes are there inside the event A into 1 by 12. So answer is 5 by 12 using the discrete uniform discrete law, right? And you can also find the probability of B. What is the probability of B, guys? The probability of B is nothing but 6 by 12, right? 6 by 12. Okay, 6 by 12. But you see here something is common in between, right? Something is common in between, right? Event A and event B, there are two outcomes which is common as well, right? Which is common. So suppose they are asking that what is the probability of A. Suppose they have already said that the probability B has already occurred, right? If it was told that, if it was told that the B has already occurred, right? Okay, so you know the occurrence of B already, right? Occurrence of B you know already, right? Okay, the B has already occurred. Okay, so the probability of getting B is nothing but what? 6 by 12. Now what is the probability of A then? So how do we write this? Probability of B given B. Okay, already B has occurred, right? So you can say probability of B we know, right? Okay, probability of B we know, but suppose we want to find what is the probability of A, right? So B has already occurred. Now we want to find the probability of A, right? So how many outcomes are there? How many outcomes are there which are common to A and B? That you have to take, right? So there are two outcomes. Okay, okay, and then what? Then you can say that probability of B, right? What is the total probability B? Probability of B is nothing but you can say that that is nothing but what? Let me again write using the discrete uniform probability law. 2 times 1 by 6. Okay, what is this 6? 6 is nothing but the probability of getting each outcome in event B, right? Okay, because there are 6 outcomes. Okay, so if you use the concept of discrete uniform probability law, right, so you can write like this. Okay, so already B has occurred. Now we want to revise the initial belief, right? We want to find the probability of A given B. Okay, what is this probability of A given B? This is the conditional probability basically, right? Because the B probability, like B event has already occurred. Now we want to find the probability of A, right? So something has already occurred. Now again we want to find the probability of A. So probability of A given B is nothing but what? That is nothing but the conditional probability, right? That is nothing but the conditional probability, right? So it is nothing but what? 2 by 6, which is 1 by 3. Suppose they are asking what is the probability of B given B, right? See, B has already occurred, right? B has already occurred, right? So what is the probability of B given B, right? They are asking. So what will be that? That is going to be 6 into 1 by 6, which is 1. It is certain event, right? If some event has already occurred, right? So what will be the probability of that? Probability of B given B is going to be 1 always, right? This is very important to keep in mind. This is very, very important to keep in mind, right? So how do we so this is how we are calculating this probability of A given B using some what? Using some you can see using discrete uniform law, right? Okay, but naturally we have to understand here something, right? What we have to understand? Suppose we have got a sample space, same sample space. Now I'm going to say that this is the event A and there is the event B. This is the event B, you can say. So probability of getting, okay, probability of getting suppose how many outcomes are there in this you can say there are 4 by 12. Okay, the probability of getting this area, okay, you can say this area, okay, and the probability of getting the intersection 1 is going to be 2 by 12, right? The probability of getting A, only A, you can say only A is going to be what? It will be 3 by 12, okay, using uniform discrete probability law, right? 3 by 12, this is 3 by 12, this is 2 by 12, this is 4 by 12, and then how many outcomes are there outside, you can say outside of these even 3 by 12, because there are 3 outcomes, right? Because each outcomes in this sample space is nothing but what? Equally likely, right? So you can assign the probability of them, right? So all these probability we have got. Now if they are asking that what is the probability of A given B, like what is the probability of A that B has already occurred, this is nothing but the common probability, you can say, between A and B, that is 2 by 12 upon the total probability. You know what is the total probability here? The total probability you can find, okay, how can you find the total probability? This is very important to understand, right? Okay, so the total probability is going to be what? The total, that will be 6 by 12, right? That will be 6 by 12. How 6 by 12? 2 by 12 plus 4 by 12, right? So it is going to be 6 by 12, right? So the answer is going to be 2 by 6, which is 1 by 3. Okay, so this is nothing but what? The conditional probability. We call it conditional probability. Okay, but there are some tools to understand this conditional probability. Right now we did not understand anything, right? We did not understand anything, guys. We did not understand anything. Okay, so what you need exactly, okay, when there will be a sample space and there are 2 events, so in order to compute conditional probability, what you need common probability, you can say. You need to find the probability of common, you can say common outcomes which are between, you can say, A and B, and you need to find the probability of B. That's it. Okay, so only you need 2 probabilities. One probability you need this, you can say this is the A event and this is the, you can say, B event, right? So if you know this 4 by 12, if you know 2 by 12, right, so you can find the conditional probability here. The conditional probability, you can say probability of A given B is going to be 2 by 12, which is a common probability, you can say, upon the 2 by 12 plus 4 by 12. This we call it total probability, right? Total probability, and this is the common one, right? You can say favorable one. Okay, so probability of A given B is equal to what? This is going to be 2 by 6, which is 1 by 3. So let us talk about the definition of conditional probability. Definition of conditional probability. Okay, conditional probability, right? So we have to understand the conditional probability. Right now we might not have understood anything, right? It's fine. ठीक है, बस आपको इतना याद रखना है कि one event will already occurred. We are trying to find the probability of another event given that one of the event previously occurred, right? ठीक है, so you want to revise the initial belief. Okay, that's it. So basically we will try to define here the probability of, you can say, A given B is equal to, this is the definition I'm talking about. The probability of A given B is going to be what? How do we read this? We read this probability of event A, okay, probability of A given that B is occurred, right? You can say B occurred. Okay, probability of A given that B occurred. This is the definition symbol that I have shown you. Now we will write here that the probability of A intersection B, the common is A intersection B upon probability of B, right? Whatever is already given, right? So this is nothing but an ordinary probability, you can say, or total probability, right? Probability of B is already given, you can say, right? Okay, and this is the common probability, probability of A intersection B upon probability of that. And how it is defined? It is defined only when probability of B is greater than 0. Okay, define for probability of B given greater than 0, because these are the ratios, right? So we need to maintain this. Okay, so probability of B should be always greater than 0. Okay, so I think this is clear, right? So you have to keep in mind what? You have to keep in mind the conditional probability shares the properties of ordinary properties. Whatever axioms we have studied, the conditional probability, okay, conditional probabilities, okay, conditional probabilities shares all the properties of ordinary probability, right? Okay, so if I say that the probability of event A should be greater than 0, you have to say that yes, probability of A given B should be greater than 0. So I am very sure that nobody might have understood anything, right? Definition, everybody will tell probability of A given B equal to probability of A intersection B. Okay, so you can say like this also, probability of, suppose B given A is going to be probability of A intersection B upon probability of A. Okay, so from the symmetry you can talk about like this also. Okay, fine. So but this is not enough, right? This is not, we have to understand basically. Okay, so what we have to do here is we'll try to understand now using some tools, right? So we know that there are some tools, okay, that I have told you. One of the very important tools that I'm going to introduce here is called multiplication rule. Multiplication rule. So using multiplication rule, we can understand better, right? Using this rule, we can understand the conditional probability better. Okay. And this multiplication rule we are going to learn using sequential description. Sequential description, which we call it tree diagram. Okay, so using tree diagram we have to understand the conditional probability definitions. Okay, now you see, suppose you can say that any event has occurred, right? You can think about like you are tossing a coin. So you are tossing a coin 3 times, right? So you toss the coins, you will get head and tail. Again you will toss the coin, you will get head and tail, head and tail. Again you are tossing the coin, you will get head and tail, head and tail, head and tail. So, or you can also understand like this, if you are tossing a coin, so you get success, you get failure. So how do we represent failure? You can say complement of the event, right? So suppose one of the event has occurred here, like event has occurred A, so this event will be complement of A, right? Okay, again you can say that this event already has occurred, the event A has already have occurred. Okay, now you want to find the what? This is very important to remember, right? Again you want to revise the belief here, right? So this event will be what? A intersection B. Okay, and this is going to be what? This is A intersection B, and this is A intersection B complement. And what is this? This is nothing but A. Okay, so now whatever event is going to occur, already one of the event has occurred, so there might be something common between them, right? Okay, there might be something common between them. Okay, like one of the event has occurred, so another event that is going to happen, so another event is going to get affected by this event, right? If the occurrence of first event is not going to affect the occurrence of second, you can say event B, so that condition will be known as what? That condition will be known as independence, right? But here in order to define conditional probability, suppose one of the event has occurred, right? Event A has occurred, you can say. Now the event B has to occur, right? So one of the event already has occurred, you can say A has occurred. Now you want to find the event A intersection B here, and this is A intersection B complement, right? Okay, and this will be A complement intersection B, A complement intersection B complement. Further you can go ahead, right? Okay, suppose there are third event as well, like this. Okay, so you can say that this is nothing but A intersection B intersection C, because there are 2 events which has occurred, right? So now we want to find the A intersection B intersection C. This is going to be A intersection B intersection C complement, right? and so on and so forth. I'm not going to fill this space, entire space, right now. So these are the event, and we are going to assign the probability of each event in these branches, right? So this will be the probability of A. This will be the probability of A intersection. So we call this probability as ordinary probability. इसको क्या बोलते हैं? Ordinary probability. What is this probability? Ordinary probability. These are called ordinary probability, guys. Probability of A is nothing but what? Probability of A is nothing but ordinary probability, right? In this case, now the event A has already occurred. So this branch will show you the conditional probability, right? Suppose one of the event already has occurred. Next branch probability is going to correspond to what? The conditional probability, right? So you will write this as the probability of, or A has already occurred. Now you want to find the probability of B, right? So this is nothing but a what? This is nothing but conditional probability. Conditional probability. So I hope now you understood that what is the conditional probability and what is the ordinary probability. Okay. The ordinary probability is going to be the initial belief you start with. Okay, suppose you have to take you can say 5 red balls from the, there are 2 boxes, okay, and you have to take 2 red balls and 2 black balls. Okay. So first of all, what is the initial belief? What is the initial belief here? You have to choose 2 boxes first, right? One of the boxes you have to choose, right? So there are 2 boxes. So you can choose box 1 and you can choose box 2, right? So that is the initial belief, right? So you have chosen some box. So you will see the probability of that. That is one of the initial belief. Then you will take out, 2 black balls. You can say 2 red balls, whatever, right? So this is very important to keep in mind. So when you start, the first stage is going to give you the ordinary probability. The second stage will give you the conditional probability. Why? Because one of the event has already occurred, right? Yeah. Now, if I want to find the probability of this, probability of this event, you can say the common A intersection B, right? The common A intersection B, right? So how can you write? How can you write? We can write this as using multiplication rule. Okay, so if we want to find the probability of this, you can multiply the ordinary probability times the probability of B given A. So you see here, probability of A times the probability of B given A is going to be equal to the probability of A intersection B. So from here you can find the conditional probability. Probability of A given B is equal to probability of A intersection B upon the probability of A. I hope this makes sense. From the multiplication rule, this formula is clear. How many of you understood this? Please let me know in the chat box. कितने लोगों को समझ में आई ये चीज? Multiplication means what? We are going to multiply the ordinary probability with the conditional probability. When conditional probability is going to happen, remember, you will be having some initial probability, okay, you can say initial belief, and then you're going to revise the model using some new information, okay. So that will be the conditional probability, right? Okay. So these are very important concepts. Using tree diagram, you can always talk about by symmetry. You can say that probability of A given B is equal to probability of A intersection B upon probability of B. So whatever is given, you have to write always in the denominator. That is very important, okay. Whatever is already occurred, that you have to write in the denominator, right? So this is very, very important to keep in mind. Okay. So from the, this is how multiplication rule works. You have to multiply the branch probabilities, probability of A, probability of B given, okay, and so on and so forth. I think this is clear for all. Okay, this is very, very important to keep in mind. Okay, I hope this makes sense. So from this concept, this is the multiplication rule that you have to remember. Okay, this is the multiplication rule. Okay, so probability of occurrence of new event is going to get affected by the probability of the event which has already occurred, right? So please remember this, how we are getting. Okay, so using this tree diagram, suppose this is probability of A, this is probability of A given B, sorry, not A given B, probability of B given A. So if you want to find the probability of A intersection B here, so it is nothing but branch का multiplication. ठीक है, ठीक है. If you want to find the probability of this, you can say A B complement, so you just multiply this and this. ठीक है. So these are the sequential description, and tree diagram is going to give you the perfect picture, right? The perfect picture. Okay, remember that. Now let us talk about the total probability. The total probability theorem. The total probability theorem. Though once I will solve the question, you will say that yes, this is the total probability theorem, right? So there we don't have to use formulas. In fact, now writing formula is also very simple for you, but you don't have to write formulas. You have to directly draw the sequential descriptions the way question asks you and find out the probability. Just multiply the branch probabilities. Now you can understand when we multiply. Okay, when we multiply, understood? So this is very important to keep in mind. Now what is the total probability theorem? First of all, suppose we have got what? Suppose we have got the sample space, right? This is the sample space, you can say. Though using this, just I'm going to give you some basic idea, but we have to use the tree diagram. So this is the sample space, and you can now partition the sample space into A1, A2, A3, right? So the very first point is what? Partition the sample space into A1, A2, A3 and so on, right? So you can say that this is going to be a partition. You see, this is A1, you can say, this is A1. Okay, now we have this is going to be your A2, and okay, there will be A3. This is A2, this is A3. Now one of the event has to occur, right? Okay, you can say that we have partitioned the sample space in 3 events. Okay, but there will be one more event, you can say B. B is one new event, you can say. Okay, now you should know what is the probability of you can say A. This is A1 common B, you can say A intersection B. This is A2 intersection B. This is A3 intersection B, right? Okay, understood? So first of all, partition the sample space into A1, A2, A3, then assign what? Then assign the probability to each event, you can say. Then have probability of AI for all I. This is the ordinary probability, you can say this is the initial belief, and then the third process will be what? Then you have to find what? You have to find the conditional probability. Conditional probability is going to be B given AI for each I. You can say for every I, right? For every I, you can say for every I. So first of all, what you have to do in order to apply the total probability theorem, first of all, you have to partition entire sample space into different events. Okay, this is the basic understanding I'm telling you, but while solving the problem, life is very simple. Okay, you can solve the problem in 20 seconds or 10 seconds also, right? I will show you. So first of all, these are the steps. First step is partition the sample space into A1, A2, A3, right? And then you have to assign the probability to each events, A1, A2, A3. Then you have to define the conditional probability for every I. Okay, these are the 3 steps that you have to do before we talk about what? Total probability. And total probability is nothing but probability of finding B. Okay, probability of finding B, right? Chalo. So this is the sample space, and these are the description that I have told you. But now let us use the sequential description. Sequential description is very, very important, right? So sequential description you have to always understand, and that will help you to understand everything, right? So you see here. So just I'm going to take both sample space as well as the sequential description and show you. Okay. Now you see both things are there. So whether you say that sample space is there and you are partitioning it, right, into different events, or you can say entire space is a sample space and there are three events A1, A2, A3. So you can say that this branch will correspond to probability of A1, this branch will correspond to probability of A2, this branch will correspond to probability of A3. These are the ordinary probability. You are starting from here, right? Now this branch will correspond to what? The probability of B given A1. Okay, I hope this makes sense, right? The probability of B given A1, right? Because this is conditional probability branch and this is the ordinary probability branch. Okay, now you have to find, suppose you are going to get B here. Okay, some understood. So what is that probability of B? Okay, this is the total probability that you have to find, right? How can we find total probability B? Total probability theorem means you have to find the probability of B, right, which comes out to be in the denominator always, right? Okay, or you can say which comes out to be in the numerator, I mean denominator will come, right? Now using the multiplication rule, what you can say, you can multiply what will be the probability of B? The probability of B is going to be the probability of B intersection A1 plus the probability of B intersection A2, the probability of B intersection A3, and so on and so forth, right? So how can you write this? What is this probability of A intersection B? This is nothing but the probability of A1, probability of B given A1 plus probability of A2, probability of B given A2. Now you might be thinking, sir, why you are writing like this? Okay, this is the application of multiplication rule, right? This is nothing but the multiplication rule. Okay, we are multiplying the ordinary probability as well as the conditional probability, right? Multiplying conditional and so on and so forth, right? Okay, so this is nothing but total probability. Okay, so you have to find the total probability here, right? Total probability will be calculated at this point after conducting all the experiment. Okay, after happening all the events, at the end of the day you have to find the total probability, right? Okay, this is very, very important to understand. Now, so how can you write this? You can write this as the probability of B is nothing but the summation over all I, probability of AI, okay, times the probability of B given AI. So probability, total probability is nothing but what? The product of sum of the product of the ordinary probability times the conditional probability. That's it. This is called total probability. Total probability क्या होता है? Sum of product of ordinary probability as well as the conditional probability. बस ठीक है, समझ, आई थिंक सबको समझ में आ गया होगा, ठीक है. So or you can also say that this is nothing but a weight, right? This is nothing but a weight. Okay, so this probability, total probability theorem is nothing but what? This is called weighted average of, okay, weighted average of what? These are the weights, you can say. Initial beliefs are nothing but weights, you can say. Right? So this is nothing but what? Total. This is nothing but weights of, or I can say average weights, right? The weighted average of P B given AI. Okay, I hope this makes sense to all. So you have to understand always this point. Okay. So what is the total probability, guys? From today onwards you have to learn. If you want to find the total probability, तो आपको क्या करना है? Simple, कुछ भी नहीं करना है. You have to just multiply ordinary probability and the conditional probability. Okay, okay. I think this is clear, right? So आपके पास situation रहेगा. They will say कि what is the probability of getting head? Okay. So getting head मतलब you don't have to focus on tail, right? What is the total probability of getting head? And whatever sequence of events is happening, right? So you just take the first event, right? Take the conditional event, okay, and then multiply them, keep on adding, right? This is the total probability theorem, we call it, right? Total probability theorem. Okay, so using this tree diagram, it is very effective to understand. If you do not understand this tree diagram, see, I'm just focusing on the truth. Okay, like the B is going to happen, right? We are not focusing on the complement of B, right? So when we want to find the total probability theorem, or we want to find the total probability, so we always go for the success. I mean, yeah, probability of getting head. Okay. At the end of the day, whatever experiment you are doing, you have to get head. That's it. The probability of getting head after after sequence of events, so you have to use the probability of you have to use the total probability theorem. Total probability theorem says that multiply the branch probabilities, right? What are branch probability? One is ordinary probability. If you focus at the first stage, the second stage is going to give you the conditional probabilities. ठीक है, पहला स्टेज हमेशा क्या देगा आपको? इनिशियल बिलीफ देगा, स्टार्टिंग फेज। अच्छा, धीरज सर के साथ आप प्रिपरेशन चालू कर रहे हो, फिर आगे का कंडीशनल हो जाएगा। नाउ यू हैव टू आल्सो प्रैक्टिस द क्वेश्चन। ऐसा नहीं है कि धीरज सर ने चालू कर दिया तो बस लाइफ में बहुत अच्छा होने वाला है, राइट? यू हैव टू प्रैक्टिस द क्वेश्चन, यू हैव टू रियलाइज, उसको बोलते हैं सेल्फ रियलाइजेशन। ठीक है, सो आई थिंक दिस इज क्लियर गाइज। ओके, सो टोटल प्रोबेबिलिटी इज दिस। अब प्रॉब्लम हम लोग जो सॉल्व करेंगे तब समझ आएगा, एंड यू हैव टू अंडरस्टैंड। सपोज क्वेश्चन इज गिवन, यू हैव टू रीड द क्वेश्चन एंड यू हैव टू अंडरस्टैंड। अच्छा, यहाँ पर टोटल प्रोबेबिलिटी लगाना है, यहाँ पर वी हैव टू अप्लाई द बेस थ्योरम, राइट? सो व्हाट इज दिस बेस थ्योरम दैट वी हैव टू अंडरस्टैंड नाउ? सो आई थिंक दिस इज क्लियर, राइट? नाउ इफ somebody will ask you what is the sum of probability of AI, sum of probability of AI, this will be always 1, right? Please remember this, it is very important, right? तो यहाँ पर जो भी इवेंट हो रहे हैं इनका सबका सम कितना आना चाहिए? 1, right? Suppose you know the probability of this, you know the probability of this branch, but you don't know the probability of this branch. You can just add these two and subtract from here, right? 1 minus, add these two and 1 minus sum of this, so you can get this branch probability. So in order to find the ordinary probability, it is very simple, right? Fine. So this is called total probability. Okay. Now we will talk about the Bayes rule, or Bayes theorem also we call it sometime. So basically I never teach direct formulas. Okay, I just want to force you, in fact emphasize on you that कि please try to use sequential description. आपको कभी डाउट नहीं आने वाला। मल्टीप्लीकेशन रूल याद रखना हमेशा, मल्टीप्लीकेशन रूल, ठीक है? Multiplication rule is very important. What is this Bayes theorem, guys? The Bayes theorem is nothing but you have to again do this, you have to partition the sample space, right? And you have to partition the sample space into A1, A2, A3, right? And then you have to have the initial belief like probability of AI, okay? And the same thing that you have to consider here also, right? तो मतलब आपको फिर से वही चीज करना है, ये सेम। See, you have partitioned the sample space, right? And then what you have to do? You have 3 steps are same for this also. Okay, ये तीनों स्टेप आपको करना है. What are these 3 steps that I have written here? So I'm just going to copy this. These 3 steps are important for applying Bayes theorem also. ठीक है? ये partition the sample space, right? You see, I have partition sample space into A1, A2, A3, then have the probability. So we are going to assign the probability of this, probability of this, probability of this, right? Okay, and sum of probability of AI is going to be 1, right? And then you're going to revise the belief given that B has occurred. Matlab, you already have got the probability of B, right? Total probability you have got, okay? You know the total probability, but you are going to revise, you are going to get back and make the decision, right? Okay, see, everything has happened already. One of the event has happened, second event has happened, you find out the total probability, again you come back, okay, based on the last event that has happened, given that we are going to find the probability of AI. Okay, probability of AI, again you are going to revise the initial beliefs, right? कि अच्छा, because of this ये हुआ था, मतलब we got head because of Dheeraj Sir box, you can say, right? There are 3 boxes, okay? One box has got some coin, one box has got some coin, one box has got some coin. So मान लो 3 box हैं, so head we have got, right? So we have got head, but from where that we got head, you can say from box 3. What is the probability that we got head from the box 3? ठीक है, मतलब we have taken out the, you can say, coin, okay, from the box 3, right, and we toss it, so we got head. So what is that probability कि वो मतलब बॉक्स 3 से ही निकाला गया था, है ना? तो रिवाइज्ड बिलीफ, बेस थ्योरम इज गोइंग टू टॉक अबाउट द रिवाइज्ड बिलीफ, राइट? तो इसको भी हम लोग कैसे लिखेंगे? Till this point you have to do, so this is nothing but the initial belief, you can say, initial belief, and this is the conditional probability, right? Now use Bayes theorem says that probability of, already we know B, okay, we know B, right? Total probability B. Now we want to find the probability of AI. तो नीचे क्या रहेगा आपका? हमेशा टोटल प्रोबेबिलिटी, यू कैन से प्रोबेबिलिटी ऑफ AI times the probability of B given AI, right, for all I. But now on top of that, what will be there? It is very important to remember, right? So you have to multiply what? You have to multiply the probability of AI times the conditional probability, right? So this is very, very important to keep in mind, right? So you can say that this is nothing but J here. Let me take J, right? And you can say this is nothing but probability of AI, probability of B given AI. Okay, one of the event you have to take in the numerator. So this is called the Bayes theorem, right? This is called the Bayes theorem. Please remember this. So the denominator talks about the total probability, you can say probability of B, and the numerator talks about what? The conditional. This is what the product of conditional and the ordinary probability. So only one of the event you have to consider, right? So आपको क्या करना है, मतलब see, these are the initial beliefs. You got something here, you got something here, you got something here. Again, this is the total probability. Now you come back and they are saying that because of this box something has happened. क्या probability है इस box से ये occur हुआ था? You just multiply these probabilities and you put this guy here and total. So this is how we apply the Bayes theorem, right? So we will see Bayes theorem problems and then we will understand this. So I think this is clear. Bayes theorem क्या होता है? So you will be given initial belief, so you have to model the new information, you can say. So ऐसा करोगे, देखो, AI is given, you are going to model here B, right? Okay, so you can find out what? If you are going from A to B, right? So you can find conditional probability here. Now suppose you have got B. Now you're going to model AI again. इसका मतलब क्या होता है? इसको मॉडलिंग नहीं बोलते हैं, इसको बोलते हैं inference, right? Inference we are going to do here. So this will give you probability of AI given B. So always understand these directions, right? What is the flow? You're going from starting to end. Now again you're coming back, right? So in case of Bayes theorem, you have to come back, okay, to find the inferences. Okay. Okay, so this is very important to keep in mind. So Bayesian inference is very, very important. So Bayes theorem is nothing but what? Bayes theorem is nothing but the systematic approach for incorporating new evidences, right? This is the systematic approach for incorporating new evidences. Systematic approach for incorporating new evidences. Okay, I hope this makes sense to all, right? So if you want to like you can model the model of the word under AI, each AI, you can say probability of B given AI, that is conditional, right? That is the modeling one. Now if you want to draw the conclusion, okay, so if you want to draw the conclusion, you have to use the Bayes theorem. That's it, right? So this is how we find the conclusion, right? So we'll see more problem in the next session, guys. Like numerical problem we will see in the next session. These are the three tools you have to remember. The important tool is multiplication tool. with the help of multiplication tool you can do anything. So you go from start to end, that is going to be total probability. But suppose you you find out total probability, but again you're coming back and making decisions, finding conclusion, right? So that is called Bayes theorem, and Bayesian analysis is very important. So we'll meet in the next session. Thank you so much for today. Yeah, we'll do some numerical questions, so आपको बहुत अच्छे लेवल में समझ में आएगा, don't worry, right? But make sure that try to revise this session.